My name is Noah, and I'm managing the platform group. This presentation, Avia, which developed Azure, prepared with me, but I will do the presentation. First of all, the good news is after this session, we're going to have lunch. Okay, so cheer up. Okay, so in the next hour, I'll try to walk us through a bit about Azure. What is Azure? How it's look like? And what have we done with replication from Azure and to Azure? Okay. So basically, replication to Azure introduced in 5.0, as most of you know. Okay, it's out there for a couple of months, getting good feedback. And in the next half an hour, I'll talk about the replication from Azure. We had many challenges there, and I'll try to elaborate this a bit more. Okay, so first of all, what is Azure? Azure is Microsoft Cloud Solution. Okay, it's released in 2010, so it's out, let's say, for quite some time. And this is an interesting article I read in August that says that there are two major, let's say, companies and players out there in the market, which is Amazon, that most of us knows, and Azure, that keep on going on and getting more and more in market share. This is the amount of numbers that I see in 2016, and it's really amazing that we see Azure is keep on growing, and I think that yesterday even we saw some presentation that said that Azure is keep on growing about this. Okay, so when we talk about replication to Azure, what is the motivation? First motivation is failover. Okay, we at Zoto today we have replication to VMware, Hyper-V, AWS, and we want to expand our portfolio to make our customer have better, let's say, possibilities. So when they can do failover to Azure, basically it's give them more flexibility. Another, let's say, use cases, as Jimmy said, okay, people want to use our solution in order to migrate into Azure, and this is very good motivation. Another point is have a cost-effective solutions, because in some cases, cloud can be cheaper. Not in all cases, okay? When you have larger data centers, it may cost a lot of money. If you do a DR to the cloud, you may end up even saving some money, because you don't have any maintenance, you don't have to pay for this, you don't have to pay for electricity and stuff like this that none of us pay. But if you're working on the cloud, basically you won't have this, you don't have to charge for this. Okay? And the last point is DR as a service over Azure infrastructure as a service. Some of our customers, when they provide DR as a service, can offer Azure as a DR service. So if their customer doesn't know Azure, don't know how Azure works, but they know that they have a solution that their backup services or the DR services is running on Azure. Okay, so this is how Azure portal looks like. I don't know how many of you even saw it. It's very user-friendly. It's very easy to navigate into. Okay, they did pretty good job as far as the UX. As far as other things, and compared to AWS, I like it more. Okay, so when we talk about the replication, basically it's the ZCA model. What is the ZCA model? ZCA means that we have only one VM, the VRA and the ZVM are running on the same machine. There are different Windows services. So basically in Azure, there are two services that we use. We have the compute services, and we have the storage services. Okay? Azure is not like Amazon. Azure is running on regions. There's no availability zone. It's much more simple. Okay? Every region, they have, I don't know, I think more than 20 or even 30 regions, but every region, okay, has a set of services that is available. So it's pretty simple. You don't have to understand what is the availability zone at all. Okay? So this is the ZCA. It's very, very much as far as the logical, like our solution to Amazon. Okay, so Azure storage is completely different than Amazon storage. Okay, so we're using the journal on the recovery. On the journal, we're using something that called block blobs. Okay, there's blob blobs and page blobs. It's a bit confusing between the two of them, but the block blob is very ideal for binary file. Okay, this is where we store all the journal. Every block, okay, can be up to 4 megabytes. There is a limit of approximately 200 gigabytes of files. Now, the recovery is located on something that's called page blob. Okay, page blob, basically, if you will run a VM on Azure, regardless to 0, okay, your OS disk will be stored on something that's called page blob. Okay, so page blob is optimal for random access. Okay, read and write. Today, it has a limitation of 1 terabyte. There are some talks that they will increase it even more in the future. It can be resized, okay, up to 1 terabyte. And as I mentioned, all the OS disk is stored over there. So when you look on page blob, it's really much look like any disk that we familiar with in Windows. Okay. Okay. So as we talk also in previous sessions, we talk about how simple it is to do the installation. So when we do the To Azure, one of the principles that we really work hard to keep on doing is making the installation simple as much as we can. So I don't know how many of you installed Azure? Was it simple? Okay, I'm glad. I'm glad to hear. Okay, so for those of you who didn't install, don't know how our ZCA and Azure look like, I'll try to walk you through. See, it's quite simple. There are some Azure terms that we need to understand. Okay, so first, when you will open the installation, you have this window. Okay, the first thing we need to do authentication. One of the things that Azure had that we don't have in AWS is when you do authentication, you're not doing authentication on 0 components. Okay, you will open this window. This window is basically Azure component that you will do all the authentication. Now, what's good about this is Azure is a multi-tenant system, as most of us know, and this is allow you to do a single sign-on. I don't know how much of you know, but each one of 0 employee can log in into Azure portal. I think that 2 weeks ago, if you will just log in with your username and password, you will be able to log into Azure. And this ability allow enterprise company to use their own, let's say, Active Directory or single sign-on in order to log in into Azure. So once we do this, okay, user is writing down his username and password. We don't store it. Okay, Zero is not storing your username and password. This is all running against Azure. Okay. So what happened during the authentication phase? When we authenticated, we get a user token after you write down username and password. And with this user token, we have the ability to, as far as the ID manager, every user has permission to several subscriptions. Okay? So what is a subscription? Subscription basically has two roles in Azure. First one, it's allow you to have a billing services. For example, if I'm an IT manager, if I'm Erez, and I want to know how much amount of money our engineering consume on Zoto, how much money our finance consume on Azure, so I can have a subscription for each group and to understand how much money at the end of the month this group consume. So first one is subscription as far as billing. The second one is about permissions. Okay, Azure has many services. Each service you can register to a specific subscription. For example, if we have the storage and the compute, Azure has many of them. So after the user is logged in to the authentication, we get a list of all the subscription that the user is allowed to see. What all the user need to do is just to choose the relevant subscription. After he's chosen the relevant subscription, we do some magic behind the scene and try to understand on what region this ZCA is running on. Just from a technical point of view, there is no simple way to do it because Azure don't have this ability on their SDK. Basically, you can tell from a running VM on what region is running, but it's a magic behind the scenes, something that involved with networking. I want to get into this. But we have the ability to calculate the region. If from some reason we fail to calculate, the user can choose a different region. Now, the main reason to do this automatically and not have the user to let's say, to choose another region is because if you consume services, if you transfer data between different regions, it even can cost you more money. So we want to spare this only on cases that we cannot automatically identify. What is the region? We have this ability. So after this, the user basically select his subscription. We get the region. We are creating something that's called application. What is the application? Application is something like this, okay? In Azure, we're creating an application. This application will use us in order to generate token. Because once we create an application, we give her a key, okay? And every 30 minutes, when we do any operation, whether it's creating VM, stopping VM, whatever you need to do, you have to do it with a valid token. So when you want to do an operation, you have to have a valid token. In order to have a valid token, you have to create an application in Azure. Okay, and every 30 minutes, what you're doing, we provide with the key that we wrote, okay, that we generate, and we say to Azure, okay, give me a valid token. If token is not valid, you cannot do any operation. This is done every 30 minutes. Now, basically, when you deploy the ZCA, this amount of expiration of application, it's almost never. One can build application in Azure, generally speaking, that says, okay, the application is valid for a month, a day, a year. Okay, you can narrow it down. Specifically in our solution, we didn't need this ability. Just for you to understand, Azure does have this ability. So after we finish and we have valid token for every operations, we end up and we creating a resource group. What is a resource group? I will elaborate in a few minutes, but we're creating a resource group and creating something that's called storage accounts, okay? I will cover this both. So basically, what is a resource group? Resource group is a logical entity, okay, that you can combine every resource out there that you will subscribe and provision in Azure has to sit on something that's called resource group. I just wrote down here just an example that says, okay, I have resource group that can contain the blobs that we saw earlier, can contain NICs and contain VMs. Now, the good thing about the resource group, if from some reason, it might sound familiar for you, if you want to delete all the resources under your resource group, you just have to delete the resource group. And yes, we did use this ability. It's very nice, but also it's very logical about this. So let's just dive some to Azure terms, just to make sure everybody here is on the same page. Azure has something that we call a VNet. VNet, basically, it's a virtual network. Okay, VNets can connect to each other, and it's limited only to one single region. Basically, VNets, it's like the VPC endpoint, that if you know AWS. Okay, so VNets is crucial for everything. Under VNets, there is something that's called subnets. Okay, what is a subnet? Subnet is a range of a lot of private IP. Okay, you have a range of private IP. So if you have 2 or 3, every VM under the same subnets can communicate with each other. For those of you who does work with Azure on a daily basis, our IT creating some also VNets and subnets for us. This is why when replicated on-prem on our VMware or Hyper-V, we can be able to replicate and even access into our Azure. So those of you who tried it, you're in the day-to-day job, just make sure you selected the VNets and the subnet that will allow you to log in into Azure from zero network. Okay, so another thing that they have is something that's called Network security group. Network security group basically manage all the inbound and outbound security rules. Whether it's if you want to block ports, enable ports, do some denied of traffics of NICs. Network security group is something that is must. Okay, you cannot work without this. There are some cases if you're not selecting network security group, you have some defaults. And about networking, networking in Azure has two types. They have public IP, which we don't use. Okay, customer can use by their own. They have public IPs and private IPs. Private IP, basically it's allocated from the subnets. Okay, and it has two ways. You can have it a DHCP or a static. Okay. So let's see how we replicate, how create VPG is looking like, and this is why I provide you with the sides of the term. So when you want to create a VPG, you have to select, the user will have to select the VNets that we saw earlier, and then obviously you must choose the subnets, the network security group, and an instance type. Now I think Shannon yesterday told me, yeah, this is supposed to be virtual machine, right? It's not an instance because instance is in AWS terms, not Azure. Azure refer VM as virtual machine. AWS refer VM as instance. Okay, so you have to select an instance type. Instance type, I'm not seeing here, but instance type have different instance type. Every instance type has different memory, amount of core, and basically is, I think the cheapest one is $100 and it goes up to even a few thousands. So our standard is day one. So if you want to do our famous re-IP ability, you will click on the advanced VM, and the re-IP will be enabled because the private IP has the ability to have static IP. Okay, so if you will just select here the private IP, okay, you can do a re-IP in Azure. So resource group is a bit complicated. It's very simple, let's say, aspects. So after this funny guy will finish upload his file into the cloud, if you have any questions about the To Azure solution, yeah. Can you go into more detail about how the re-IP function works? Basically, you have the re-IP. It's something that Azure provides us. Okay, for every IP you have the private IP. Okay, you can just ask them. I mean, it's on the SDK. It's not something that is complicated as far as the re-IP. I don't know how Azure is doing this behind the scene, but for us as a developer, you have this ability on the SDK. It's a non-issue. Other question? Okay. So, replicated from Azure. As you know, we working on in those days. There is combined efforts for both VRA team, core team, platform team. Everyone is combining and joining effort in order to do this. So, I will cover a bit about the motivations and talk about the snapshot mechanism. I know the snapshot is not many people like this word, as I heard yesterday, but I try to explain the details and why it's a bit different. And we talk about all the reflection changes we did. So motivation, the obvious one is the fail back. I'm looking, from my perspective, it's even raising the confidence of those companies that is afraid to go into the cloud. So assume that you know that you can go out from Azure, so why not give it a try? Okay, so let's give it a try. Well, I'm having my cool VMware or Hyper-V solution. I'm replicating into Azure, so if it's not working, I can replicate back. So this is the first motivation. And the second one is pretty much as tied to the first one, but it will raise confidence for mission-critical application to be running on the cloud from day one. Okay, we always talk about, okay, let's just fail over into the cloud, but going forward, we want to see more and more people using the cloud from, let's say, from day one. So the application will be started from the cloud. So this is from Azure is very important that reason. So a bit about the challenges. Okay, so cloud is somewhere, right? We don't know where it is, so we cannot have the drivers as we know in the hypervisor. We cannot intercept the IOs. We cannot just catch this IO before it's writing down to the storage and just throw it into our backup VRA or recovery VRA. So how to do it? This is a huge challenge on the cloud in Azure, and basically it's also relevant for AWS. Okay. The second issue is more like an engineering issue. As most of you know, Zero started with supporting of VMware, okay? So VMware in the code is everywhere, okay? The awareness of us being on a hypervisor environment, in almost every place in the code that you will take a look, you will see an hypervisor entity, hypervisor concepts. So there is all the protected flow are coupled with hypervisor entities. So Azure has basically two type of storage. They have something that's called the standard storage, okay, and the premium storage. The standard storage have RPO of seconds. The main reason for this is there's no limit to the amount of snapshot you can take on the storage itself. Why is that? I don't understand exactly why, okay, but it's referring to the premium. Premium, as far as Azure, you can take snapshots every 10 minutes. Okay, it's limited to 100 snapshots. Main differences: standard storage is not run. I mean, the premium is running on SSD. Okay. My guess is the differences. So you can ask yourself, okay, so premium storage is much, it's cost more money than the standard storage. How come the standard storage has an unlimited number of snapshots? It may have to do how Azure is doing the standard storage behind the scene. Okay, maybe it's not a, let's say, maybe it's a fragile storage and it's not like in the premium storage. So we do have this limitation. We are working and we do get even better performance and try to do something less than 10 minutes, but officially, as far as, let's say, Azure, you can only take it every 10 minutes. Okay, so going next to the second challenge, as far as the protected flow. So as I mentioned previously, ZVM use hypervisor reflection, okay? Public cloud entity collection, when up until now, we only do failover to the cloud. When you do failover, the amount of things that you need to collect from the environment is very simple, okay? You don't have to collect anything. You don't have, so it's all the collection was very slim, okay? And when we try to understand it, see what is the cloud entities versus the hypervisor one, there was no mapping between them because the world is a bit different, okay? So any idea how we managed to overcome this challenge? For those of you who are not working on this. Okay, so let's just see a bit about the hypervisor world. So in the hypervisor world, we have this entity. We have a VM. We have something that's called volume. On VMware, we also aware if this volume is an RDM volume or not. We have hosts, as most of you know. We have data store. We have networking. We have NICs, and we have clustering. If you would look and compare to AWS, so AWS have instance, they have something that's called volume. Buckets, if I'm comparing this to all the blob and the storage accounts, so they have blobs. They have subnets. They have something that's called VPC. VPC basically, it's more like the network security group and Azure. They have NICs. They have region, like in Azure, but they also have availability zones. Availability zones in every region, you have several availability zones. So if we look in Azure, Azure have entity that's called VM. They call something that's called volume, but now they have something that's called storage account, which is different. They have VNet, they have subnets, so it's basically, it's not the same entity, okay? So the first thing we did, we tried to map the world. We asked ourselves, what is what, okay? So let's say the simple thing is VM is a VM. You can call it in a different name, but eventually VM is a VM. Okay? So we take a look on volume. Volume is volume, right? In every place. I don't care if it's one is implementing it's in RDM volume. For me, you know, it's a volume. Next was pretty simple. Data store was a bit of a challenge because we ask ourselves, what is a data store? So we all, you know, under the conception of what is a data store on VMware, and we're all familiar with. But basically, we compare the buckets and the storage account. Basically, this is the data store. So we can treat them as equal. When we look about networking, basically the subnets and the network that we used to have on the hypervisor, we did manage to compare between them and to make them also equals. About host, okay, there is no host on the cloud, but host is a valid question, okay? Do I have host? No, I don't have host in this environment. So I can live with this. And also about clustering, okay? There is no clustering, but this is also a valid question. Okay, so we come up with, and this was a lot of work, just doing all this, let's say, thinking on how to approach this. We created something that's called an agnostic reflection, okay? So basically, after we do the mapping, we look on the world and say, okay, what we Azure need when you do a failover, when you do a create VPG? Is this really necessary for the system as far as, you know, components and from the engineering perspective, does it really care what is the, let's say, the hypervisor or platform type that he's running? And surprisingly, the question was that is not that matter. Okay, it's not that matter. So we create something that's called platform reflection query, or I just creating a cool name that says PRQ. I don't know if it will catch, but let's give it a try. So we try to simplify the world and say, okay, and guys, when you look in this, I'm talking from a developer perspective, okay? So if you look at the code those days, you will have this new entity. Okay, so okay, we set a VM. We will create something that's called platform VM. It's irrelevant for almost everything. VM, the amount of core that we have, that this VM have. What is the amount of CPU? Okay, the amount of memory. A VM, it's a VM. As far as the volume, almost the same volume. What is the size of the volume, right? So we created this entity. As far as NIC, if you want to know the MAC address, you know the IP address. It's supposed to be very simple. Data store is also the same, okay? If you want to know the URI, if you want to access the data store, you want to know where it's located, it's very easy. And also we created something that's called network, host, and cluster. So, for example, if we will run some scenario in our code and say, okay, do I have cluster in this environment? So if you go to the cloud, it will say, no, I don't have it. But our system won't crash, right? Also same goes for hosts. So basically, the challenge was, okay, I know that all the hypervisor reflection has many things underneath. This is, let's say, something that took 5 years of knowledge is running over there. So all this agnostic layer, we have all the native reflections that we know. We have the hypervisor reflection that is relevant for Hyper-V and VMware. We have the reflection of AWS. We have the reflection of Azure. All this native reflection is on the lower layer. So we created an abstract layer on top of it, and it's creating on the fly. Why it's creating on the fly? We know that our reflection collection and reflection indexing is very smart today. We don't want to cause any degradation. Okay, there's a lot of things going on there, so we create it on the fly only when we need. So basically, we're converting the agnostic reflection, okay, to the new entities. So the calling code just consumed the new layer. It's irrelevant for him. And most important thing is we created a background also for our next challenges, for example, if we want to pick the from AWS, the work that we did and from Azure, it's a lot of infrastructure and a lot of things that we did behind the scene, but eventually, as far as I'm not talking about the replication itself in any platform, it will be a challenge, but as far as all the system, creating the VPG, a bit of failover, all of the flows that can be, let's say, platform agnostic, as far as the system can use this new infrastructure, eventually it will allow us to provide a better, let's say, fast development of new platform in the future. This was one of the main goals, okay? We do a lot of work right now in order to save money down the road. Okay, so let me just give you some glimpse of how it's looked like. Some of you are familiar with this view, right? Of creating the VPG. So when you want to create a VPG, basically you care about two things, right? So you want to pick the VMs, for example, and you want the size of the VM. So if you look in this slide, in order to answer those two things, for us as user, okay? So do I need to know if I'm running on Azure, AWS, Hyper-V, VMware? No. The only thing I want to know is how many VMs, what exactly the VMs that is running there, and what is the size of each VM. So basically, on the flows in the system, okay, as most of you know, we are consuming the information from the VQ, and the VQ is calling now the new platform reflection, and the platform reflection is aware, okay, I know basically right now I'm running on Hyper-V, okay, or running on Azure, so I will go to Azure and consume this information. Or I'm running right now on vCenter, so I will go to vCenter and get this information. And the cool part is there's this higher layer of creating VPGs, consuming the VQ. It's relevant to them, so there is no work over there, just on the lower layers. Okay, so basically, I do like to answer some questions if anyone has about this, because it's I have many times. So I do like to answer questions if someone have any questions. Yeah, Yossi. I was surprised that you didn't ask question earlier, you know? Just I was looking for you, but yeah.
Well, you mentioned the limit on the number of API calls.
Mm-hmm.
The fact that we actually do rejection right now.
Mm-hmm.
So those two coupled together. Do you have any estimation of how much, how many VMs will be able to replicate how many VPGs in Azure? And do you have any plans of going past that in the future?
Okay, so let me just make sure I understand the question. As you're saying about, okay, so I will try to make it even more general. There is limitations on Azure. When we work with the API for everything, there is limitations. If you have a subscription, every subscription can have limitations of the amount of code that you do it within an hour, okay? So it's basically, you can even have the amount of NICs that you can create it, okay, the amount of cores that you will create it. Everything is very, very limited. And basically, I can give you the number right now, okay? I would say that we are doing a lot of effort in order to make it more visible to the customers to understand, okay, I'm doing an operation under a subscription right now, and the subscription is hitting the limit. One of the main problem is assuming that you have 100 VPG, okay? So 100 VPG, you don't know if you will fail over at once, okay? So assuming that you have a core limit on your subscription that says on any given time, you can run up to 10 cores, okay, in your subscription, hypothetically speaking. So assume that you will create 100 VPG, and at this moment, after you create it, you didn't have any one VM running on Azure, right? So when you would do a failover, if you do for once, great. If you didn't hit the limitation. But what happened when we do all 100, this is a challenge. Okay, so on every step of the road, whether we're creating a VPG or doing failover, we're working hard on doing all this validation and make it visible to the customer to understand, okay, you hit the limit. Okay, so we have a clear message. You don't have to even approach Zero support. He will understand that his subscription has limitation. Go to the Azure portal. Within a click, he can increase the amount of core limit or NIC limit or whatever. Okay, that answer your question? Everything is limited in Azure. This is the KB. I didn't wrote it here, but you have limitations for everything. Okay, we are well documenting them. However, as I said, we don't count only about the KBs. KBs is out there. Some of us read the KBs, some of them not. We do need to do this work and make all the message very clear to the customer. By the way, another challenge that, as far as all the limitations that Azure have, they have a very, very restricted naming mechanism. If you want to create a VM in Azure, if you want to create a VM with special character, you won't be allowed to do it. If you want, there is also a KB about this that says you cannot create this type of names in Azure. And basically, we did handle this as far as, and I'm speaking also to a customer, if you will create something on Azure via Zero, okay, and you will have a VM that it's previously his native name does not correspond with all the limitations of Azure. So we try to create it. If we will not try to create it, we have this validation mechanism, naming mechanism. Avia wrote it. So basically, it understands for every operation that you do, whether it's creating VM, creating resource group, creating storage accounts, what you provide with them a name, it's checking if it's a legal name as far as all the limitations and the validation, and if not, we creating a different one, okay? So in order to provide the customer of a more fluid system and not just give him an error, said, okay, you have a VM with a not valid name. So you will see the VM. You might see some missing characters over there, but we're doing this magic behind the scene. And it's what's very important, okay? Other questions? We have 10 minutes. I mean, I finish much earlier, so. Yeah.
Question regarding the snapshots. Where are they stored? Doesn't it mean that you require much larger storage, not replicate for snapshots?
Okay, so the question was where that snapshot is stored, and if there's any limits. So the good part is when you create in a snapshot, it does store on Azure. This is why also Azure limits you, okay, to the amount of storage, the amount of snapshot that you have. Okay, so we don't have to I mean, we create the snapshot, okay, we take the snapshot, but basically this, when we call to the API and we have the snapshot, we said, okay, give me this snapshot and that snapshot, okay? We don't have to store all the snapshots in the ZVM. Other questions? Okay. Okay, so thank you very much, guys.